This year has been absolutely devastating with many natural disasters, of which wildfires is only one of them. As you all know, there's a proliferation of geospatial data, from satellites to ground level to aircraft. How do we use all this data? One way is, of course, to use machine learning when we talk about big data. Now the problem is, how do we make this all interoperable? Here OGC Testbed is the ideal way to innovate and develop new standards for geospatial data. And let me introduce you to two scenarios here. Let us first introduce the fuel load scenario we did. So here you see OGC Web Map Services, or WMS, provide data to visualize or render maps. So during Testbed 16 a limitation was found in its capability of training machine learning algorithms, but using the Get Legend graphic option, WMS can provide an image with the map legend, which can help understand and interpret the color codes. However, in order to train a machine learning algorithm, we would need numerical data in a machine-readable format. This limitation can be overcome if the WMF offers a styled layer descriptor. This is an XML file encoding of the legend information in a machine-readable format and accessible using getStyles operation. So far so good. But here's the problem. SLD and these operations are described in OpenGIS styled layer description SLD specifications, which is an optional extension to the WMS standard. Unfortunately, being an optional extension means that not all WMS instances will implement it or will implement it fully. In our case, we could use the getStyles operation, but the SLD document retrieved was empty, leaving the machine learning algorithm with no way to interpret the maps. This is an important limitation to using WMS with machine learning, because even if this is technically possible, the standard does not enforce the proper implementation, and thus many WMS implementations will not be compatible with machine learning algorithms. If you are interested in more lessons learned and the full detail of this scenario, please have a look at our ER, which is on the OGC portal. Now we show you our water body scenario. Training data are needed in machine learning to build mathematical models, as we all know, that can automatically detect certain features in the data. However, establishing these initial data sets can be incredibly daunting. One of the tasks in OGC Testbed 16 was to determine how well OGC standards can support machine learning in the process of building algorithms to automatically detect water bodies in Sentinel-1 scenes. For training data, two datasets were chosen. The water body datasets of lakes, rivers and glaciers in Canada, the CanVec series as labeled data to determine areas of standing water. This CanVec vector dataset is the best available hydrological data source that covers Canadian territory and is based on multiple sources. And second, as raw data, the Sentinel-1 synthetic aperture radar, also known as SAR data, was used. However, the CanVec hydrological dataset was never developed for machine learning. Ideally, a data pair is needed, so labeled data that is derived from the raw data. Now, with images from different time periods, the water area might have changed, and as such, part of an image is labeled as water, while there may not be standing water in the raw image, as indicated by the red arrows. So to conclude, OGC services like WMS for training datasets do work, but keep the data pairs together and use the file identifiers for metadata, such that, for example, date, lat long, image ID is also included in the label. Here again, if you want more details, please visit our ER on the OGC portal. We hope that the results of our training data for machine learning ER will set some new standards and enable businesses to more efficiently use machine learning algorithms with the proliferation of data to better assist disaster response, in particular in this case, wildfires. Thank you very much for listening.